Okay, so last time we were talking about, well, let me just show you the client program that I have up here. I actually have the entire client program that we're going to try to get running by the end of class today. Let me give it that. We'll see how far we get, but I'm just going to uncomment one line at a time as we get to that part of the lecture. So we are working on the insertion operator. And we talked about the fact that the insertion operator is going to have to do two things. Number one, it's going to have to take its right operand and send that right operand to the stream object, which is its left operand. Remember, cout is an object of type OStream. Secondly, our insertion operator is going to have to return, whatever its left operand was, because when we're done applying that insertion operator, what we want to have left there in that position that I have highlighted now is simply cout, so that the next thing we do is cout insertion operator and then the string plus. So again, insertion operator, two things: send its right operand to the stream that is its left operand, and secondly, return its left operand. Here's the problem we're going to encounter, though. And I have this written out here in a comment. So let's look at this comment for a second. In order for a feet inches member function to be called, the calling object must be a feet inches object, right? There's no way to call a feet inches member function if the calling object is something other than a feet inches object. Hopefully that makes sense. I guess if it doesn't make sense in a way, I guess that's okay. You can take my word for it. Just not going to work. So that presents a problem, right? Because here in this statement, I told you that C++ considers the left operand to be the calling object, and the calling object, or sorry, the left operand here is not a feet inches object. So here's what we're going to have to do. We could overload it as just a regular old-fashioned function, the way we've been using functions since week 3 of the class. In other words, a global function. Instead of a class member function, we could overload it as a global function. So that would look something like this. Remember, I said we're going to be returning the left operand. The left operand is an OStream object, so that means the return type is going to be OStream. I'll talk about the ampersand in a minute. The name of the function is going to be operator insertion. And then the parameter is going to be the right operand, which is of type feet inches. And as we know, since it's an object, we're going to use const ampersand. Call that. Okay, so just a global function. Any questions about that so far? Like, before I keep going, I just want to say, does it make sense that we could do that as a global function? I mean, I'm not expecting necessarily that you would have known that, but I'm telling you, right? Not only can we overload operators using member functions, we can overload operators using just regular old-fashioned global functions. The problem with doing it as a global function is that now we don't have access to the private data members of the feet inches class, right? So here's how we solve that problem in C++. We put, actually, you know, so sorry, before I finish that sentence, I just have to fix something. Yeah, let me back up a little bit. You may recall that when we talked about overloading operators as member functions, we said that the number of parameters is always one less than the number of operands. Okay, I actually have that written down here. Let's paste that right here so you can see it. When we overload an operator as a member function, the number of parameters equals the number of operands minus 1. Hopefully, that makes sense, right? Because the left operand is the calling object, so the right operand is going to be the one parameter. So for example, when we overloaded the plus operator has 2 operands, 1 parameter. Okay. When we overload an operator as a global function, the number of parameters is going to be equal to the number of operands because we don't have a calling object now, right? So the left operand is going to be the first parameter. The right operand is going to be the second parameter. Okay, so I have to put in my left operand here. My left operand is of type OStream. I'm just going to call it out or outstream. You could call it outstream. I'm just going to call it out. So there's my 2 parameters. The first parameter corresponds to the left operand, which was cout. The second parameter corresponds to the right operand, which was F1 or whatever the feet inches object was. Any questions about this header? The header on this function right now.
Could you describe that whole line of code?
Yes. So return type, and I'll just say, first of all, I realize that we haven't done a lot with OStream objects. So this may be new, and that's okay. I'm just telling you what we want to return is going to be an output stream, for example, cout. So that's why it's going to be a type OStream. And I'm just telling you that whenever you use OStream or iStream or OFstream or IFstream, whoa, as a return type or a parameter, it's always going to just have ampersand on it. You're never, ever going to see OStream by itself without an ampersand on it. So that's the return type. There's the name of my function. And then I've got my parameter list. The first parameter corresponds to the left argument over here, right? So when I say, I'm looking at this line right here, line 11, when I say cout F2, the left operand is cout. So that's why the first parameter is of type OStream. And the right operand over here is F2, a feet inches object. So that's why the second parameter here is a feet inches object. Anything in there that you want me to say again or talk about more?
No, that's perfect. Thank you.
All right.
Could you go over the OStream return type one more time?
Sure. So I may just say exactly the same thing again. I'm not sure how to say it differently, but we've got, so here's the expression that we are trying to write a function to evaluate, right? We're overloading the insertion operator. The left operand, if you look at that expression, is cout, which is an object of type OStream, right? So if you were to go look at this file, the IOStream file, somewhere in that file, you're going to see something along the lines of OStream cout, right? There's a variable named cout declared, and it's of type OStream.
Oh, okay, that makes more sense. Thank you.
Okay. Okay, so that explains why we have two parameters instead of just one. Okay. So I would, before I went on that little digression, I was talking about the fact that this is not actually going to work because we don't have access to the private data members. So let me go ahead and write the body of this function. And we'll just pretend for a second that we have access to those private data members, just because I want you to see what it is we are trying to do here. So basically what I want to say here is print me dot feet print me dot inches and then return. Okay, so this is actually our final version of this function. So it's okay if we want to stop and talk about this for a while, that would be a good thing. The only thing that we haven't solved yet is the problem of not having access to the feet and inches data members. So if I try to run this right now, I'm going to get a compiler error that says, oops, you're trying to access a private data member of a class. Okay. So anything I should talk about here? I guess so. So just to talk a little bit more about this variable out, the reason that we are using a variable there and not just saying cout is that we want our insertion operator to work if the thing on the left turns out to be a file instead of the console window, right? So we may not have gone over in much detail writing stuff to a file, but we have talked about reading stuff from a file, right? Pretty sure. Anyway, and so I guess what I'm getting at is that, you know, later on, the next time we run this program, we might want to say out file F2 instead of cout F2, and that should work. So what we're doing here is we are saying I can use any variable of type OStream on the left side of that insertion operator, and whatever that is, that's where I'm going to send the output. Okay, so that's why we use out there and not cout, and that's actually something to sort of be careful about, because that students run into trouble with that sometimes. Even students who understand that that should be out forget and put cout instead because they're so used to typing cout there. So just be careful. So at this point, it should be making sense why this is going to work and do what we want it to do. So if it doesn't, you should let me know and maybe try to articulate sort of what's a little fuzzy still. Aside from the private data member thing. Okay, so I'm going to keep going. Here's how we solve the private data member thing. In our class declaration, oops, we're going to put the prototype here in our class declaration, even though it's not actually a member function, okay? And then what we're going to do is we're just going to put the word friend in front. And what that is that's a message to the compiler. It's telling the compiler, okay, you're going to see a function, a global function with this header, when you do, it's okay for that function to access my private data members. Okay, because it's a friend. Any questions? This is now done. I'm going to run it. It's going to work. He says confidently. Nope. What did I do? Let's see. Did I not save it? I didn't save it. It's always the first thing to check, right? There we go. Okay. So everything worked the way we wanted it to. Any questions about anything that just happened right there? Our insertion operator worked the way we wanted it to. It's the bottom line. Okay. So let me just go through some of the more important points of that process that we just went through, because turns out that this is by 95% of the questions I get from students who are stuck on their programs in this lesson is about this right here. So I'm going to just go over a couple things again. So I just have a few comments down here that I want to go over. In order for a feet inches member function to be called, the calling object must be a feet inches object. All right, we already talked about that. So what that means is we cannot make the insertion operator a member function because the left operand is not a feet inches object. Therefore, skipping this one for now, therefore, in this situation, we use a friend function. Okay, this is the only situation where you will need to use a friend function, right? So my suggestion is don't even think about friend functions until you get to a point where you're looking at your code and you're going, oh, darn, I need the left operand to be something that's not a feet inches object. I guess that's what, I guess I need to use a friend function. Okay. And then this one right here is just saying the same thing again, except in more general terms. Instead of talking specifically about the insertion operator, I'm just saying in general, we cannot overload an operator as a member function if the left operand is not an object of the class. Okay. Questions about any of that? Okay, I guess I'm going to move on to the next thing. If you're all getting that as much as the silence makes me think you are, then you're in excellent shape. Let's look at this next little bit of code here. I'm going to move the start of the comment down to there. And I'm actually going to just pretend that's not there for now. In fact, I'm going to get rid of it. Okay. What do you think? Is this going to work? And why or why not? You don't have to answer the why or why not part if you just want to guess yes or no. It should work. Oh, so far we have a vote for yes and a vote for no. and 19 people not voting. Okay, so let's look at this expression right here. We wrote a plus operator. Right, that's exactly the answer that you that I would expect that you should give, given what you know. This should not work because we wrote a plus operator. Oh, okay. We wrote a plus operator that takes a feet inches object on the left and a feet inches object on the right. What we have here is a feet inches object on the left and an int on the right. We haven't written the we have not written a plus operator to handle that situation. Okay, so your instinct should be to say, no, that's not going to work. However, I'm going to tell you something that you probably didn't know unless you've studied this before. And that is that when C++ is faced with evaluating an expression, and there's an operator like the plus here, it does everything it possibly can to try to make it work. It does everything it possibly can to find an overloaded function that's going to allow it to perform that operator. Including, one of the things it will try is it will try converting the int into a feet inches object by looking for a constructor that takes one argument. Do we have a constructor that takes one argument?
Yes.
Yeah, we do, right? We used it right here when we declared F2. So what's going to happen, and if I was in Visual Studio right now, I would probably go into the debugger to actually show you what's going on here. But on line 20, actually the very first thing that's going to happen if you're in your debugger is it's going to jump to the constructor that takes one argument, because C++ is going to construct a temporary feet inches object using that constructor, so it can then add F3 plus whatever that temporary feet inches object is. Does that make sense? So it turns out that surprisingly, this is going to work. Oh, you can actually just see that. Oh no, let me try. Did we get it?
You didn't save after
didn't
you
save.
uncommented.
Thank you. Try that again. See how many times in 1 hour I can forget to save, right? Okay, so here's my F1 is now 46 feet 7 inches, which is correct because apparently F3 was 4 feet 7 inches, right? Any questions about what just happened there? So that's just something you have to be a little bit careful about. It's actually pretty easy to get used to. The only thing that's tricky is that you need to be able to look at this line of code and say, oh goodness, there's no actual explicit function call there, but there are actually two functions being called, right? The one argument constructor is going to get called, and then my operator plus function is going to get called. Okay, next question. Is this inefficient? No, I mean, there really isn't a more efficient way to do it, right? We have to, you know, it's either that or it just doesn't work, right? So I'll take something that works over something that might be inefficient, but it's not really. So I guess what I'm thinking maybe you're getting at is, function calls are sort of inherently not super efficient, right? So if we can avoid function calls for the sake of efficiency, that can be a good thing. But in this case, we don't really have a choice, right? So, and it's not really inefficient enough that it's going to matter. Okay, next question. What about this? Is that going to work? No guesses, no votes. All right. Then I will tell you. What did I change? I switched F3 and X around. Right? It used to say F3 plus X. Now it says X plus F3. And so what I'm getting at is this statement right here. We cannot overload an operator as a member function if the left operand is not an object of the class. So, is that going to work? Right, that's exactly what we're doing here. We are trying to overload an operator as a member function, but we want the left operand to be an int. Can't do that. So what do we do when we encounter that situation?
Flip it around.
Well, we're not the client programmer here, we're the class programmer, right? And we don't want to tell the client programmer, sorry, you can never have an int on the left side. We want to make it so that the client programmer can do that if they want to. So
we will convert the X into feet inch.
Well, how are we going to do that? Well, let me back up a little bit, okay? So looking at this, we cannot overload an operator as a member function if the left operand is not an object of the class. What does the very next sentence say there in my notes? Therefore, in this situation, instead of using a member function, we're going to have to use a friend function. This is exactly what we did with the insertion operator when we realized that the left operand was not going to be a feet inches object. Okay. Everyone understand how it's exactly the same thing we just did with the insertion operator? We realize we want to allow the left operand to be something other than an object of the class, which means, and so hopefully, that'll get burned into your brain, right? As soon as you notice that, you should immediately just say, oh, that means I need a friend function. Okay. So let's go back to the class. Everyone okay with that part about why we need a friend function? Anyone want to talk about that more? Okay, so basically what I'm going to do is I'm going to scratch this. I'm going to get rid of it because that's a member function. That's overloading the plus operator as a member function. I'm going to scratch that. I'm going to start from scratch and I'm going to overload it as a friend function instead. Okay, so the return type is still feet inches. The name of the function is still operator plus. The difference is now I'm going to have two parameters instead of just one, right? Because I need the left operand and the right operand. And it no longer makes any sense to say const. Const only makes sense at the end of the prototype when there's a calling object, right? The word const there that I have highlighted means the calling object cannot be changed. But with a friend function, there is no calling object, right? It's not a member of the class, so there's no calling object. So it never makes sense to have const out at the end if it's not a member function. Any questions about this prototype? Okay. Let me get rid of this one because we are replacing it. And then down here in our function definition, still the return type is still feet inches. It is not a member of the feet inches class, so we're going to get rid of that part. It's just a global function, right? We need both of our parameters here. Okay, and then we're going to do exactly the same thing inside here, but instead of the calling object, we are using left, right? And instead of the parameter other, we've now named it right. So this is going to be left.feet. This is going to be left.inches, left.feet, right.feet, left.inches, right.inches. Okay. Anybody want to talk more about that before I try running it? All right, let's give it a try. Okay, looks like it all worked. There's my client. I said F1 gets X plus F3. So now F1 is 46 feet 7 inches. Any questions about that?
What if you called instead of F3 another integer?
Well, then you'd be adding two integers together, and so it wouldn't have anything to do with our class at all. So in other words, C++ would evaluate that expression. The answer would be an integer. Then, I don't know if you're asking about the next step or not, but the next step would be now we're going to try to assign that to a feet inches object, right? You think that's going to work?
Probably not.
I think yes,
Okay. You want to say why you think it'll work?
Shouldn't it?
because like we can, for example, the F2, we have the F2 example, the number 3 that we put in F, so it will be 7. Whatever in X
Right. So,
will,
well, so I guess what we're talking about is after C, so the question is what, I guess I should just type it out, right? The question is, what if we say this, right? X plus 14, right? 42 follows a single parameter. That's what's happening here, yes. So Joseph said 42 basically just follows the single parameter constructor to become a feet inches object. And the answer is yes. Right here in this case, the value 42 is getting sent to that single parameter constructor, and it's turning it into a feet inches object so that I can then add it to F3. Okay, right. But now that I'm done with that, and I'm on to the next step, which is let's say we're here, we've got this situation. X is 42, 42 plus 14 is 56. What happens when I say F1 gets 56? Is that going to work? Can I do that? Can I assign an int on the right to a feet inches object on the left? Or even, let's even simple, let's just say that. Same question, right? Can I say F1 gets 14? Anybody have any guesses on that? Is that going to pass or not? Is that going to compile? So here's the deal. Assignment is just another operator. Well, this line of code right here has nothing to do with any friend function we wrote, right? I mean, we wrote a friend function for plus and we wrote a friend function for insertion, but there's no plus going on that line and there's no insertion going on that line, right? So fundamentally, I'm gonna answer the question about whether it's gonna work now, okay? Fundamentally, the answer is no, because you can't assign something of type int to something of type feet inches. However, that assignment operator is just another operator, just like the plus operator or the insertion operator, right? And I told you a few minutes ago that when C++ is faced with a situation like this, it's going to try everything it can do to make this work. And so just like we did up here to make this work, C++ is going to convert that 14 into a feet inches object by calling our one argument constructor, right? So I'm going to kind of play with that a little bit. I hope this doesn't go too far afield, but first of all, let me just demonstrate that it is going to work. Okay. Oop. So it compiled fine, and it just says F1 is now 14 feet 0 inches. But what I just want to emphasize that that's not just sort of, you can't just look at this and say, oh, C++ knows how to do that, I'm not going to worry about it, and move on. It's important to understand what's happening there, which is that the constructor is getting called, right? So just for fun, I'm going to play with the constructor here a little bit. I'm going to say, see out, converting in feet to see. I'm going to do this if, so I'm going to have this print only if it's got one parameter. So I'm going to say if in feet is not equal to 0 and in inches is equal to 0. Right? Everyone understand why that's only going to be true if there's one parameter? Okay, I'll take that as a yes. See how converting in feet to a feet inches object. Okay, so all this is going to do is it's just going to let us know that the one parameter constructor has been called. So if I try this now, we'll see that, okay, we converted 3 to a feet inches object right here, right? This is kind of interesting, and now I'm wondering why it got called twice, but I'm not going to worry too much about that. Then down here, we converted 42 to a feet inches object right here on this line. to make it so that I could, no, not on that line, on this line, right? I converted 42 to a feet inches object right there. And then here on this line, I converted 14 to a feet inches object so that I could assign it to F1. Okay. And I'll be honest, I'm not sure why those are getting called twice sometimes. But I don't want to take the time to try to figure that out right now. Okay, probably should move on. That was just not a complete digression, but not part of the core, I guess, of what you need to get out of this discussion. Any questions about friend functions and overloading the plus operator? Okay, let's keep going down our client program. It looks like the next thing that we want to overload is the less than operator, so that we can compare two feet inches objects. Okay, so actually, let me just back up a little bit. There's something that I meant to say, and I just remembered that I forgot to say it. This trick we're using that makes it so that I can use an int on the left, or I can use an int on the right, or I can just have both of the operands be feet inches objects. An alternate way of solving that problem would be to just have three different functions, right? One function that gets called when both operands are feet inches objects, one function that gets called if the left operand is an int and the right operand is a feet inches object, and then a third function that gets called if the left operand is a feet inches object and the right operand is an int. Usually when I teach this stuff, about 10% of the class turns in the assignment and they do it that way, right? Three different functions for each operator. Don't do that, right? Because of this little trick, what that means is instead of having three different plus operators to make this all work, we only need one plus operator. Okay. All right. So we're overloading the less than operator. It looks like I need the left operand to be things other than feet inches objects sometimes. So that means that I'm going to have to overload this as a friend function, right? So I'm going to add it to my class declaration. Friend, it's going to return a bool. The name of the function is going to be operator less than, and it's going to have two parameters, just like these two parameters. Okay, so there's my prototype. Let me come down here and do the function definition now. Oops, that's not what I meant. Return type is bool. This is not a member function, so I'm not going to do the feet inches colon colon. So the next thing that I need is the name of the function. There's my parameter list. Oops. And so I'm not going to spend a lot of time talking about how to write the body of this function. I'm just going to throw it out here. If left.feet is less than right.feet, then clearly I need to return true. If left.feet is greater than right.feet, then clearly I need to return false. And then if neither of those is true, that means that the feet are equal. And so I just look at the inches, right? I'm gonna just return left dot inches is less than right dot inches. Okay? So if the body of that function is a little fuzzy, don't worry too much about it. You can go take a look at it in the notes. Any questions about less than? So now hopefully, looks like I got an extra L there.
So this would work even if one of the operands was an integer?
That's correct. And we're going to test that out because we actually use an integer as one of the operands right there, right? Oops. Okay, so let's give it a whirl. What did I do? Didn't
Save?
save. Yep. One of the, it's a, I guess it's a forgetting to save day. Okay, so F2 is less than F1. And X is less than F1. Okay, so, you know, if I was really working on this, I would test it a lot more exhaustively than that, but that'll do for us for now. And let me, while I'm thinking about it, let me get rid of that extra line in the constructor. Okay, so that was pretty quick, right? We overloaded the less than operator. There was nothing new there at all. I could have just left that as an exercise, but I figured I would just do one more for you. Any questions about overloading the less than operator?
Can you review how it's able to work with, even if it's not a feet inches, it's an integer?
Yes, let's go over that. Basically, the problem is, so C++ is looking for a function named operator less than that has an int on, that has an int and a feet inches object. There isn't one, right? So what C++ is going to do is it's going to use the one parameter constructor that we provided, and it's going to call that and use it to construct a feet inches object so that then it can just call our operator less than function with the 2 feet inches objects. So it's basically temporarily turning this integer into a feet inches object by calling our constructor on it.
I see.
Okay. Anyone else?
So how does it compare it? Like it takes like the inches, like how does it compare?
Well, it compares it how we told it to, right? We wrote the code right here.
Okay.
Right, so when C++ sees this, it's going to call our constructor to convert this X into a feet inches object. And then once it's done that, that allows it to call our operator less than function. And it executes the statements in the operator less than function. Anyone else? Okay. One more to go. And then I do have a few sort of random observations that I just want to make about what we have been talking about. So the one more function we want to overload is this guy here, the plus equals operator, right? So I'm going to overload the plus equals operator. I am not going to use a friend function in this case because it doesn't make any sense to have the item on the left be an int, right? This operator is only intended for situations where the left operand is a feet inches object. So it's just going to be a regular member function, not a friend function. So going to my class, return type is going to be feet inches. Name of the function is operator plus equals. There's going to be one argument, one parameter, because this is a member function. And so there's two operands. So there's going to be one parameter. And I am changing the left operand, right? So I'm not going to have it be constant. Okay. Need to be super, super careful about understanding what the plus equals operator does. I think most of you probably have this, but it's easy to forget. What does it mean to return value? Well, okay, good question. Let's talk about the plus equals operator and what it does, okay? The plus equals operator in C++, even if I'm just dealing with ints, there's two things happening, right? Lots of students get this wrong in the assignment. So just be careful about this. This is kind of a more humorous thing to get wrong, because it seems like every semester I get a student who does this wrong, but they're really confident that they got it right. So much so that they tell me that the sample output that I provided is wrong. Okay, so just make sure you get this, and also just know that I'm very confident that my sample output I'm going to give you is correct. So in this case, forgetting about classes for a minute, if I just have an integer, two things are happening here. One is I am changing the value of the calling object. But the other thing that's happening is that it's actually getting evaluated to something, right? It's evaluating to, in this case, 11. So if I were to run this statement, well, actually, no, what is I? I is nothing. Sorry, I guess I meant X here. Let's do this. And I get 7. Okay. So two things happening, just like is usually the case with operators in C++, right? I think I talked about how the fact that there is the function, the expression is evaluated, and also there is a side effect. Okay, and often in C++, when we are doing our programming, we ignore one or the other of those because it makes our code better if we ignore one or the other of them. But when we're overloading the operators, we just have to pay very close attention to that. Make sure we write the operator so that it does the same thing that it does on primitive objects. Okay, so the plus equals operator increments the left operand. That's the side effect. And also evaluates to whatever the end result of that is. Okay, so in this case, this line of code would change the value of I to 11 and also would print the value 11. Anyone want to ask a question about that? Okay, so I'm going to delete this if everyone's okay with that. Okay, so back to our plus equals operator. I think I'm done with the prototype. No const there because I'm changing the left operand. It recreates the object. No, it doesn't recreate anything. It modifies the calling object. And then it's going to make a copy of the calling object so that it has something to return, if that's what you mean. Okay. Okay, so let's write our function. It's going to return a feet inches object. It is a member function of the feet inches class, so I need my feet inches : : Okay, so what I'm going to do here is I'm going to be kind of clever. I'm not going to do this adding from scratch. I'm going to use the plus operator that I already wrote. So what I want to say here, the first thing I want to do is I want to say, let the calling object equal the calling object plus right. Does that make sense? And then the second thing I want to do is return the calling object. Any questions? Those are the two steps. So the first step, I'm just going to say star this gets star this plus right. Okay, because I already wrote a plus operator. So this is perfectly valid code. It's going to go call my plus operator to add those two feet inches objects together. And then return the calling object. Okay. So this is actually kind of cool because you'll notice that this code inside my plus equals operator doesn't refer to feet inches objects or anything like that. Doesn't refer to feet data member, doesn't refer to the inches data member. What that means is that anytime you are writing a class and you want to overload the plus equals operator, and the plus operator has already been overloaded, you can just copy and paste this code. All right, and there's going to be at least one, if not two or three opportunities later on in the course for you to do exactly that. So try to remember that when you are writing the plus equals operator, that should be like the easiest code that you write this semester. Okay, let me run it if there are no questions. Let's see, did I uncomment that part of the client? Yes, I did. Okay. So there's my 53 feet 7 inches. Any questions about plus equals? Okay, so I just have a few random observations now to make about operator overloading. First thing is, I just want to emphasize that we could always do any of this without friend functions, because another way around this would be to write those functions that we made into friend functions, just write them as old-fashioned global functions like we've been using before we studied classes, but then have them call member functions that actually do the work. Okay. All right, so I'm going to say if that sentence didn't really make sense, you don't have to understand the details of that. I just want to throw out there for you that there's always a way to get around using friend functions if for some reason you didn't want to. They are just there as a convenience to make our code a little bit simpler. Okay. Here are some other things. Actually, I think I'm just going to put the lesson up here so we can take a look. Okay. You can overload any operator in C++ except for these four: the dot operator, the scope resolution operator, the dot star operator, and the question mark colon operator. So in C++, I should know this, but there's something like, I don't know, maybe 40 or 50 operators. You can overload any of them except for those four. Okay. You cannot create new operators, right? You can give new meanings to already existing operators, but if it's not already an operator in C++, you can't create a new one. The operators that you overload retain their precedence, right? So you can't make it so that multiplication comes after addition. Their associativity, that's the wrong, I should change that. That should say associativity. That just means, do you go left to right or do you go right to left when you're evaluating them? Can't change that. Can't change the number of operands that they take. The binary operator has to be a binary operator. A unary operator has to be a unary operator. Can't change the number of operands. Finally, the assignment operator has to be overloaded as a member function. You cannot overload it as a friend function. Okay. Any questions about any of that? Those are just kind of random stuff that you'll probably never need to know, but just in case, there it is. Okay, one more thing we're going to talk about, and this is a little bit of a side point. It's very mechanical, so if you get confused or if this causes your project to not work, just forget about it. Okay, I don't want this to be the thing that you get stuck on. You know, if it's causing you trouble, just take everything having to do with namespaces out of your code, and then maybe, you know, during office hours or in lab or something, get a little help with it. Don't let it hang you up. But I'm going to try to get you into the habit of using namespaces. So whenever we write a class from now on, we're going to put it in a namespace. What that means is that in order to use things that are defined in that namespace, you have to indicate, the client programmer, has to indicate that you're doing so. Okay, so step one, as the class programmer, you want to put your class in a namespace. So put this at the top of your header file, and then put a closed curly brace at the very bottom of your header file. Okay, that puts your class declaration in a namespace. Then you do exactly the same thing for your implementation file, so that all of your member function definitions and friend function definitions will also be in the namespace. Then switching to the perspective of the client programmer now, what that means is that if I'm the client programmer, I can't use your class unless I am using your namespace. So I just put this statement at the top of the file of my client file, and that makes it so now I can use your class. Okay. This is really just like not telling you anything at all about why this is doing what it is. It's just telling you the mechanics of doing it and getting it so that it will work. And I'm pretty happy with that for now. I think, you know, it can start to make more sense as we go. I also have a link here to a complete description of how namespaces work. And I think I'm just gonna stop there. I realize I did the namespaces thing kind of quickly, but it's right here in the lesson. You can go back and take a look at it. Just real quickly, let me go ahead and just do that. So in my case, I have my header file and my implementation file combined into one. So I'm only going to have to do one namespace. So here I'm going to say namespace, let's call it CS feet inches, open curly brace. And then at the bottom of the file, close curly brace, and then technically everything in between should be indented. Okay. So if I try to run this now, unknown type name, feet inches. Oh, did you mean CS underscore feet inches? Okay, so basically it's saying you can't use feet inches because you haven't told me that you're using the CS underscore feet inches namespace. Right, so the way to fix that in the client is just to the top, I'm going to say, all right, compiler, I'm going to tell you now I'm using the namespace CS underscore feet inches. So now it will let me compile that. Okay. All right. So we're over time just a little bit. Any last questions before we go? All right. Have fun in lab. I will see you on Monday.
Thank you.